Usually, when we talk about graphic design, we tend to picture this like totally pristine, frictionless environment.
Oh, absolutely. A completely sterile bubble.
Right. You're sitting there in a minimalist studio, just pushing these perfect vector shapes around on a high-res display.
Choosing the exact Pantone mix.
Exactly. And it feels entirely decoupled from the physical world. It's just pure, unadulterated visual strategy. But the moment you hit Command P or send that packaged file off to a commercial printer,
that is where the illusion completely shatters.
yeah, that digital dream just slams headfirst into a very heavy, very industrial reality. I mean, we're talking about massive chainsaws cutting through timber, giant chemical vats, boiling wood chips.
Unbelievable amounts of energy consumption.
Yes, and these sprawling global supply chains. Historically, the things we design to be beautiful, to be communicative, they've actually extracted a massive toll on the planet.
It's kind of the ultimate paradox of the profession, isn't it?
It really is.
We are literally in the business of creating visual order. But the hidden cost of that production is often profound environmental chaos. The industrial mechanisms that mass produce our work are inherently violent to natural systems.
And that tension, that exact paradox, is what we are plunging into for today's deep dive. We're pulling all our insights today from this incredibly detailed, really pragmatic source. It's chapter 14, titled Greening Graphic Design, straight from the definitive book Graphic Design Reference plus Specification.
It is such a vital text for any working professional.
It really is. And hey, just a quick note for you listening, if you want a physical copy of this desk reference for your own studio, you can just scan the QR code on your screen right now.
Or just click the book link we provided down below in the description.
Exactly. And, if you find these deep dives valuable and want us to keep unpacking this kind of dense material, subscribing to the channel is the absolute best way to support us.
Highly recommend hitting that button.
For sure. So, our mission today is really to shortcut your path to becoming a truly sustainable practitioner. Because the text proves that going green doesn't actually require you to blow up your entire workflow.
No, not at all. You don't have to abandon your high-end clients or go live off the grid.
Right. It's about surgical informed interventions. We are going to trace the entire life cycle of a design project today.
From the initial brainstorm in the studio straight into the forest.
Through the paper mill, onto the printing press, and finally into the consumer's hands.
And those interventions, they really have to begin long before ink ever meets paper. The text establishes early on that true sustainability isn't just a production choice at the end.
Right.
It's a fundamental shift in how a designer evaluates the entire lifespan and purpose of a project.
Well, and we all know the industry is just absolutely saturated with marketing buzzwords right now. I mean, you see eco-friendly or green slapped on literally everything.
Oh, from reams of paper to server hosting packages, it's everywhere.
Yeah, and the source actually draws a very rigid line separating those terms from actual sustainability. It defines sustainability as this three-legged stool.
The balanced use of natural, social, and economic resources.
Exactly. It's an approach that ensures we don't jeopardize future generations. So if you specify this plant-based material that technically saves a tree,
but it relies on an economic model that brutally exploits the agricultural workers harvesting it.
right, then it completely fails the sustainability test.
Because the social and economic pillars are just as load-bearing as the environmental one, the text points out that green usually just implies a really narrow concern for ecological impact.
Like just focusing on recycled content and ignoring everything else.
Precisely. Sustainability demands a macro view of the entire capitalist mechanism surrounding the product.
Which naturally leads into what the text calls the first step in a four-step sustainable workflow, which is just getting your own house in order, greening the studio.
It sounds so rudimentary, but it's critical.
Yeah, like switching to compact fluorescent or LED bulbs, buying FSC-certified office paper, tying into renewable energy if your city offers it. But the real friction the text highlights here isn't the light bulbs.
No, it's cultural. It is about educating your coworkers and your partners.
Yes, because if the principal designer is fiercely dedicated to sustainable sourcing, right, but the account managers are still out there promising clients these glossy, heavy metal stamped, totally unrecyclable pieces just to close a deal,
then the whole system collapses internally.
Exactly. The culture has to align.
You really have to build a culture of intention across the entire firm. And that internal alignment gives a studio the leverage to tackle the second and arguably the most difficult step in the workflow.
Oh man, step 2. evaluating the project.
Yeah, the text asks a question here that is genuinely confronting for anyone who makes a living producing physical media. It asks the designer to look at the creative brief and just ask, does this piece even deserve to exist?
I read that line and honestly had a minor existential crisis on behalf of our entire industry.
It's heavy.
Because we are literally trained to just execute the brief. Like, a client comes to you with this massive budget for a direct mail campaign, and your first instinct is, I'm going to make the most visually stunning direct mail piece in human history.
You want to win an award for it.
Right. But pushing back philosophically, asking the client if the piece even needs a physical footprint in the real world. That requires an immense amount of professional capital.
It completely challenges the default behavior of the industry.
Yeah.
The text forces us to ask, are we printing out of necessity or are we just printing out of habit?
Wow, yeah. Habit is a powerful thing.
It challenges designers to analyze the strategy itself, not just the artifact. So could this highly produced catalog serve a dual purpose?
Like acting as both a mailer and an in-store display.
Exactly, which instantly cuts the print run in half. Or could the entire campaign be fundamentally reimagined as an interactive digital PDF?
Or a targeted web experience, which just eliminates the physical supply chain altogether. You're essentially trying to design the waste out of existence before you even draw the first sketch.
That's the ultimate goal.
But okay, let's assume the piece survives that interrogation, right? It absolutely must exist in the physical world.
Then we move to the third step.
Designing for a greener solution. This is where a designer's daily habits inside their layout software start to trigger real-world ecological consequences. I'm talking about the mechanical minutia of the file setup.
This is exactly where theory becomes practice. A perfect example from the text is the physical sizing of the document.
Oh, this blew my mind.
Right, because if a designer just arbitrarily decides to make a brochure 8.75 inches wide instead of a standard 8.5 inches, just because they like how that proportion looks on their monitor.
That tiny quarter-inch difference can have catastrophic downstream effects.
Huge effects. Commercial printers use standard-sized, massive press sheets. That slight width increase might mean the printer can only impose 4 layouts onto a parent sheet instead of 6.
Which means the remaining paper is literally just sliced off and thrown away as trim waste.
Exactly. A purely aesthetic, uninformed choice generates exponential garbage.
And the same principle applies to ink coverage, doesn't it?
Absolutely.
Because we've all seen those ultra-premium corporate reports, right? The ones flooded with solid black ink from edge to edge.
They look very dramatic.
They do. But the mechanical reality is that flooding a sheet with that much heavy ink requires more chemical solvent to clean the presses. It takes more energy to dry the sheets so they don't stick together.
And it introduces massive amounts of pigment that have to be aggressively bleached out later when that paper is inevitably recycled.
Right. So the text frames the strategic use of white space not just as this cool modernist design principle, but as literal conservation of resources.
It's a very practical choice. Furthermore, the text pushes designers to think about the product's end of life. Designing for a greener solution means specifying water-based adhesives for the binding.
Oh, instead of those synthetic resin-based glues.
Right, because those synthetic glues release volatile organic compounds and they totally contaminate the recycling stream. It also means embedding explicit, visually clear recycling instructions right onto the packaging itself.
So the end user isn't just standing in their kitchen guessing whether the box goes in the trash or the blue bin.
Exactly. Take the guesswork out of it.
Which brings us to the ultimate handoff. The fourth step, green production. This is partnering with the right printer and choosing the actual physical substrate. And this is a critical threshold because the source points out a deeply sobering statistic.
It's a tough one to read.
75% of all communications pieces end up in landfills within a single year.
12 months from the press to the dump.
It's brutal. And because of that massive turnover rate, the materials we select at this stage are just paramount. To really understand those materials, we have to look way past the swatch books and the glossy paper samples on our desks.
We have to look at the forest.
The origin point of the entire graphic design supply chain.
And this is an area fraught with deeply entrenched industry narratives that the text systematically dismantles.
Yeah, the most pervasive narrative is definitely the bank account analogy. Paper and timber conglomerates love to market this idea that for every tree they harvest for a pulp mill, they plant 2 or 3 saplings in its place.
That's a very comforting thought.
It really is. The logic suggests this perfectly balanced ecological ledger, like you withdraw $1, you deposit $1, and the forest remains whole.
It is a brilliant marketing concept that completely ignores biological reality.
Completely.
The text explicitly addresses this. Yes, in places like the United States, annual tree plantings do technically exceed the number of trees harvested for industrial purposes. The sheer volume of wood is increasing.
But you're replacing a complex ancient ecosystem with a monoculture crop.
Exactly. A commercial tree plantation is no more forest than a field of corn is a wild prairie.
Right, it's a high-yield agricultural product versus an old-growth forest. The text highlights boreal forests and rainforests, which are areas that have developed naturally, completely untouched by industrial human activity for over 100 years.
And anyone who understands basic biology knows these ancient systems hold immense biodiversity.
But the industry argument often counters that, right? They say that by concentrating timber harvesting in these high-yield, fast-growing plantations, they're actually protecting the remaining old-growth forests from being touched.
They do make that claim.
So does the source material support that defense?
It views it with extreme caution. While plantations produce fiber very quickly, the ecological debt of clear-cutting a natural forest to establish that plantation in the first place can never be repaid by saplings.
Because you've destroyed the original cycle.
Right. An intact old-growth forest contains a continuous cycle of life. You have ancient canopy giants, understory growth, and these massive decaying nurse logs that regulate the soil's moisture and fungal networks.
And they are massive carbon sinks.
Exactly. So when you clear-cut that to plant neat, identical rows of a single, fast-growing pine species, you completely obliterate the soil health. You destroy the wildlife corridors, and you release centuries of stored carbon straight into the atmosphere.
Man. And the text notes that deforestation is responsible for roughly 20% of the world's annual carbon dioxide emissions.
That's a staggering figure.
It really makes you want to just advocate for a total, immediate ban on virgin fiber. Like, why not just legislate that all paper must be made from 100% recycled waste?
Because the mathematics of global consumption simply do not allow for it. The text provides a really harsh dose of reality here.
There just isn't enough trash.
Exactly. There is not enough recoverable waste paper on the entire planet to satisfy the ravenous global demand for packaging, communication, and sanitation products.
Plus, the wood fibers actually physically degrade each time they are recycled, which is the mechanism we are going to explore a bit later.
Right. You constantly have to inject fresh, strong fiber into the global supply chain just to keep the recycled material structurally viable. Therefore, humanity will rely on virgin forest products for the foreseeable future.
So as a designer, you are trapped in this paradox. We desperately need virgin fiber to maintain the paper supply, but acquiring it through traditional clear-cutting is an ecological catastrophe.
It's a tough spot to be in.
So the middle ground the text presents is sustainable forestry. And the absolute gold standard for verifying this practice is the FSC, the Forest Stewardship Council.
The FSC is critical, and the reason they are so trusted is because they are an independent, non-governmental third-party certifier.
So it's not just an industry trade group giving themselves an A+.
Exactly. They aren't grading their own homework. They deploy accredited auditors to enforce incredibly strict environmental and social standards.
What kind of standards?
They mandate that forest ecosystems must remain functionally intact after logging, they protect indigenous land rights, and they ensure the long-term economic well-being of the local workers.
But the logistical challenge there seems insane to me. How do you prove a sheet of paper came from a specific, responsibly managed forest? Because once a tree is stripped, pulped, bleached, and rolled into this pristine white sheet, it looks exactly like paper made from illegally clear-cut timber.
Visually, it's identical.
So how does the FSC actually guarantee the provenance of the material?
Through a really rigorous, audited logistical framework called the chain of custody.
The chain of custody.
The text emphasizes this concept heavily. The chain of custody tracks the physical fiber from the exact moment the certified tree is felled, through the transport trucks, into the pulping mill, out to the paper manufacturer,
To the wholesale merchant.
and finally onto the commercial printing press.
It's essentially an unbroken forensic audit of the material's entire life cycle.
Exactly. Every single entity that handles that wood or paper must possess their own active FSC chain of custody certification.
So if an FSC-certified paper mill sells their paper to an uncertified merchant, the chain is broken.
The chain is broken, and the final product cannot legally bear the FSC logo. Crucially for designers, this means the commercial printer you hire must also be certified.
Wait, really? So I can buy the most sustainable paper on earth, but if my printer hasn't passed the FSC audit, they can't print the little tree checkmark logo on my design.
It is absolutely illegal for them to do so. The accountability is incredibly strict.
That is wild. And to illustrate what this looks like when it's executed properly, the text details the operations of Domtar, which is a major paper company operating up in Canada.
Their process is fascinating.
It really is. They harvest jack pine for pulp, but their regeneration process is this crazy intersection of industrial scale and microscopic ecological care.
Right, because instead of just clear-cutting and abandoning the land or, just planting generic mass-produced seedlings, Domtar engages in highly localized genetic preservation.
The mechanics of it are just wild.
Yeah.
When they harvest a specific stand of jack pine, they employ these specialized workers to physically collect the seed cones from the tops of the exact trees they just cut down.
They gather the local cones.
Yeah, and they process those specific cones to extract the seeds. Then, after preparing the harvested site, they fly over it in small aircraft and drop those exact seeds back onto the soil.
They are meticulously ensuring that the genetic adaptations, the specific resilience that those trees developed over thousands of years in that exact microclimate, are reinstalled right back into the ground.
It is forestry operating at the level of DNA preservation.
That is the profound difference between sustainable forestry and industrial timber farming. It balances the economic necessity of extracting virgin pulp with the scientific mandate to maintain the specific ecological stability of the source.
So we've established that sustainably harvested virgin fiber is unavoidable, and we know to look for the FSC certification. But when a designer actually opens a paper specimen book to source this material, they just slam into a wall of impenetrable chemical acronyms.
Oh, it is daunting.
It's like trying to read an advanced organic chemistry textbook. And if you don't understand the specific chemical vocabulary, you really cannot make an informed choice.
The text fully acknowledges that this jargon is one of the primary barriers to adoption for designers. Demystifying the terminology regarding chemical bleaching and fiber sourcing is absolutely essential.
Okay, let's navigate the chemistry then, starting with the alternatives to wood pulp. You often see papers marketed as utilizing agricultural fibers or agricultural residues. To the layperson, those sound identical. They both imply plants.
They do, but the ecological footprint of the two is vastly different.
Okay, break that down for us.
Agricultural fibers refer to non-tree crops that are grown specifically and exclusively to be turned into paper. Think of a massive commercial farm planting hundreds of acres of hemp or kanaf.
Got it.
Agricultural residues, conversely, are the discarded byproducts of crops that were cultivated primarily to feed people.
Ah, okay. So we're talking about the stalks of wheat, the husks of corn, or the fibrous remnants of sugarcane after the sugar has been extracted.
Precisely. And from a sustainability standpoint, residues are far superior.
Because dedicated agricultural fibers require huge tracts of land, intense irrigation, and fertilizers just to make paper.
Exactly. Whereas residues capture a waste product from the existing food supply chain, the environmental toll of growing the plant has already been amortized by its primary use as food.
That distinction is so crucial. Moving deeper into the chemical side, the text spends significant time discussing VOCs, or volatile organic compounds.
Very important term.
We hear this term thrown around constantly with household paints, but in the context of graphic design, where are these VOCs coming from, and what is the actual mechanism of their environmental damage?
Well, in commercial printing, VOCs are primarily emitted as vapors from the petroleum-based solvents used in traditional inks,
Okay.
and also from the highly aggressive chemical washes that are used to clean the press rollers between print jobs.
So it's the ink and the cleanup.
Right. And the danger isn't just that they are toxic to inhale for the press operators, though that is obviously a serious occupational hazard. The broader environmental damage occurs when these vaporized organic chemicals hit the atmosphere.
Because they don't just dissipate harmlessly.
No, they don't. Under the influence of sunlight, VOCs react chemically with nitrogen oxides in the air to form ozone.
Wait, I thought ozone was a good thing.
Well, while ozone high in the stratosphere protects us from UV radiation, ground-level ozone is actually the primary constituent of urban smog.
Oh, wow.
Yeah, it damages lung tissue, it stunts plant growth. So when a designer casually specifies a specialty ink that requires heavy petroleum solvents, they are directly contributing to the photochemical smog in the city where the piece is actually printed.
The chemistry of the printing process is deeply consequential, but the chemical violence begins long before the paper even hits the press, specifically during the bleaching process.
The bleaching process is historically notorious.
Right, because we all know lignin is the culprit behind paper turning yellow and brittle.
Right.
Like an old paperback left out in the sun.
Yes, the lignin polymer naturally occurs in wood to give the tree rigidity.
But to make the bright, archival white paper that designers love, paper mills have to aggressively strip that lignin out. And historically, they did this using elemental chlorine gas.
And the chemical reaction between elemental chlorine and the organic lignin molecules is disastrous. As the chlorine breaks down the lignin, it creates a highly toxic family of byproducts known as dioxins.
The text is very, very clear about the severity of dioxins. Even in microscopic amounts, they are persistent organic pollutants.
Which means they do not break down in the environment.
Never. They bioaccumulate in the food chain, and they have been definitively linked to severe reproductive and developmental problems, immune system damage, and cancer.
And the immediate vector for these dioxins entering the environment is the mill's effluent.
Effluent, meaning the liquid waste.
Right. Effluent is the millions of gallons of liquid wastewater discharged by the manufacturing facility. If a mill is using elemental chlorine, those dioxins are just washed out in the effluent, seeping into the local water table, contaminating rivers, and settling into the sediment.
That is terrifying.
Yeah.
Because of the massive public outcry over dioxins, the industry eventually had to pivot, which gave rise to the alphabet soup of acronyms you see on paper swatches today. ECF, PCF, and TCF.
Yes.
The big three.
Understanding the hierarchy of these three acronyms is perhaps the most actionable technical knowledge a designer can possess. So let's break down the mechanics. What does ECF actually mean?
ECF stands for elemental chlorine free. This is currently the standard for most virgin paper. It means the mill has abandoned pure elemental chlorine gas.
Okay, so what do they use instead?
They use chlorine derivatives, most commonly chlorine dioxide. The chemical structure of chlorine dioxide is much more efficient at oxidizing the lignin without forming the same massive quantities of dioxins.
So it's a vast improvement over the old methods.
It is, but it still relies on chlorine chemistry, meaning some low-level toxic discharge is still entirely possible.
Okay, so it's better, but it's not the ideal. Then we have PCF, which stands for process chlorine free. And the text specifies this term is reserved exclusively for recycled paper.
That's right. And to understand why, we have to look at the mechanics of recycling. The waste paper arriving at the mill is a totally chaotic mix.
Right? It could be anything.
Exactly. It might contain old magazines that were bleached with elemental chlorine decades ago. So the mill cannot legally claim the paper is 100% free of chlorine entirely.
Because the old chlorine's already baked in.
Precisely. What PCF guarantees is that during the current process of breaking down that waste, de-inking it, and rebleaching it, absolutely no new chlorine or chlorine derivatives were introduced.
So what are they using to bleach it then?
They utilize benign bleaching agents like oxygen, ozone, or hydrogen peroxide.
Got it. Which leaves the absolute gold standard for virgin fiber, TCF. Totally chlorine-free.
TCF means the paper is made from 100% virgin pulp, and absolutely no chlorine or chlorine derivatives were used at any stage of the extraction or bleaching process.
So again, they rely entirely on oxygen-based chemistry.
Exactly. The resulting effluent from a TCF mill is dramatically less toxic. The text notes that the scientific community overwhelmingly prefers TCF over ECF.
So if I am specifying a virgin paper stock, TCF is the ultimate environmental spec.
Without question.
Okay, one final piece of mill vocabulary before we look at the energy toll. Mill broke.
Mill broke refers to the internal manufacturing waste generated right on the factory floor.
So like the paper trimmings, the rejected rolls, the scrap.
Yes. The mill simply sweeps this up, drops it right back into the hydropulper, and turns it back into paper.
It is highly efficient closed-loop manufacturing. But as we transition into understanding the realities of recycling, the existence of mill broke severely complicates what the word recycled actually means to a consumer.
Oh, it really does. But to fully grasp the recycling dynamic, we first have to understand the sheer thermodynamic force required to make paper in the first place.
It's massive.
It is. The pulping process, specifically the dominant craft process, which involves boiling wood chips in a highly pressurized soup of sodium hydroxide and sodium sulfide just to dissolve the lignin.
It requires unimaginable amounts of heat and kinetic energy.
Unimaginable.
The text provides a statistic that just stops you in your tracks. To manufacture just 1 ton of paper, the average mill consumes 33 million B2 of energy.
33 million.
To contextualize that, 33 million B2 is equivalent to the total energy consumed by 4 average American households over an entire month.
For just 1 ton of paper.
Yes. And when you scale that up to a massive corporate catalog run that requires hundreds of tons of coated stock, the energy footprint is astronomical.
Historically, that energy was generated by burning mountains of coal, which made paper mills some of the worst polluters on Earth. However, the text acknowledges a really significant industry shift over the last 2 decades. Driven by strict environmental regulations and intense pressure from corporate buyers, many mills have totally modernized their power grids.
Yeah, you see logos for Green E certification on paper specs now, right?
Mm-hmm.
Which indicates the mill offsets its consumption by purchasing wind or solar credits.
Exactly.
But there is a fascinating mechanical nuance the text raises regarding how some mills generate their own power on-site using biomass.
Yes, the closed-loop energy model. This goes back to that craft pulping process we just mentioned. When the wood chips are boiled, the resulting chemical soup separates the usable cellulose fiber from the dissolved lignin and other organic wood resins.
And this leftover toxic, sludgy byproduct is called black liquor.
It sounds horrifying.
It really does. But instead of dumping it, modern mills have these massive recovery boilers. They spray this black liquor into the furnace and actually burn it.
Because the organic wood lignin acts as fuel?
Right. And it generates high-pressure steam that spins turbines to power the mill. Furthermore, the burning process separates out the pulping chemicals, which fall to the bottom of the boiler, are collected, and then reused to boil the very next batch of wood chips.
It is an incredible feat of chemical engineering. And because the fuel source is organic wood matter rather than fossil fuels, this energy is technically classified as renewable biomass.
But the text applies a very critical lens here.
It has to. It advises designers to look really closely at the air pollution data from these facilities. Just because the fuel is technically renewable doesn't mean the combustion gases belching from those smokestacks are harmless to the local community's air quality.
So it requires a designer to look past the shiny renewable energy badge and ask harder questions.
Absolutely.
Which brings us right back to the great recycling debate. If the virgin pulping process is so chemically and energetically intense, the obvious solution seems to be maximizing our use of recycled paper. Let's dive into the friction surrounding the word recycled.
Let's do it.
Because if a client demands a 100% recycled stock and the designer finds the sheet labeled just recycled content, what are they actually getting?
They are highly likely getting a heavy dose of that mill broke we defined earlier, alongside other forms of pre-consumer waste.
What else counts as pre-consumer waste?
It includes the massive trim rolls sliced off at the commercial printer before the job is even shipped, and unsold overruns. Essentially, it is paper that was manufactured but never actually fulfilled its destiny of reaching a consumer.
Wow. And the text reveals that pre-consumer waste accounts for roughly 20% of the reclaimed fiber in the industry.
So when a ream of cheap copy paper proudly advertises 30% recycled content, the reality is often that the mill is simply feeding its own floor sweeps back into the machine.
And marketing its basic manufacturing efficiency as some sort of environmental crusade.
It is classic misdirection. The real environmental heavy lifting is done by utilizing post-consumer waste, or PCW.
PCW.
This is the material that was actually printed, shipped, used by a human being, placed into a recycling bin, and successfully diverted from a municipal landfill or an incinerator.
So when a designer really wants to move the needle on sustainability, they must completely ignore the generic word recycled and specifically mandate high percentages of PCW.
But pushing for 100% PCW introduces mechanical realities that designers really have to understand to manage client expectations.
Because the physical process of recycling paper is highly destructive to the material itself.
We have to look at the physics of a cellulose fiber.
Uh.
Every single time a sheet of paper is thrown into a hydropulper,
Which is essentially a giant industrial blender, right?
yes, it violently churns the paper to break it back down into pulp. And during that process, the physical length of the wood fibers is sheared and shortened.
So the fibers aren't infinite.
Not at all. The text notes that structurally, a wood fiber can really only survive this violent recycling process about 6 times.
Only 6 times.
Maybe up to 9 times in highly specialized facilities before it just becomes microscopic dust that simply washes away in the water.
Wow.
And as the fibers get shorter with each cycle, the resulting paper naturally becomes weaker, rougher, and less structurally sound.
This is why you cannot infinitely recycle a premium glossy magazine into another premium glossy magazine.
Exactly. Eventually, those short fibers must be downgraded into newsprint, then into rough cardboard, and finally into products like toilet paper, where structural integrity is no longer a major requirement.
The structural degradation is one major issue, but the chemical reality of removing the old ink is where the process gets incredibly murky.
It's a massive challenge.
Because when post-consumer waste arrives at the facility, it's totally covered in heavy commercial inks, synthetic glues, and varnishes. You'd have to strip all of that out just to get white pulp again.
This is the de-inking process, and it relies heavily on a mechanism called froth flotation.
Froth flotation, how does that work?
They churn the pulped waste in massive vats of water mixed with surfactants, basically industrial soap. Okay.
Then they inject air into the bottom of the vat. As the bubbles rise up through the pulp, the ink particles detach from the wood fibers and stick to the bubbles.
Oh, that's clever.
It is, and it creates a really thick, dark, chemical foam at the top of the vat, which is then skimmed off.
And what remains after skimming that foam is the sludge.
The
A
sludge.
text highlights this de-inking sludge as a massive, deeply controversial environmental liability, because you are essentially consolidating all the chemical sins of the original printed pieces into this concentrated, heavy, wet mass.
The disposal of this sludge is heavily debated. It is voluminous, and while some of it is incinerated or put in landfills, the text points out that in certain regions, this sludge is actively reprocessed and sold as agricultural fertilizer.
Which is genuinely terrifying when you consider the supply chain of the waste.
Absolutely.
I mean, the waste paper being recycled today might include materials printed years ago, long before modern bans on certain heavy metals and pigments took effect. You are potentially taking legacy toxins like lead or cadmium, concentrating them in a de-inking vat, and then spreading that toxic sludge over fields growing human food.
It is a stark reminder that in industrial systems, pollution rarely disappears. It simply changes states and relocates somewhere else.
Very true. Now, the text does emphasize that despite the massive energy costs of the pulping process and the toxic realities of de-inking sludge, comprehensive life cycle analyses still decisively conclude that recycling paper is far superior to letting it rot in a landfill.
Because in a landfill, it generates potent methane gas.
Right,
Right.
exactly.
But understanding those mechanical flaws is why the text doesn't advocate blindly demanding 100% PCW for every single design project.
The friction of cost and quality is just too high for most clients.
Right. Because if 100% PCW is incredibly expensive to clean and structurally weak, what is the pragmatic solution for a designer who's trying to balance a client's budget with environmental responsibility?
The text advocates for mixed sources as the optimal sweet spot.
Mixed sources.
A mixed source sheet intelligently blends the structural integrity of virgin fiber with the environmental benefits of diverted waste.
So you're looking for a paper specification that incorporates roughly 20 to 40% post-consumer waste.
Right, because that percentage is high enough to actively support the municipal recycling market and keep waste out of landfills.
But it's low enough that the paper maintains excellent brightness and strength.
Exactly. The remaining 60 to 80% of the sheet is comprised of high-quality TCF virgin pulp sourced explicitly from an FSC-certified forest.
It perfectly represents the realities of the market. You get commercial-grade printability without the exorbitant luxury pricing of a 100% PCW sheet.
Which makes it so much easier to sell the sustainable choice to a budget-conscious client.
But, you know, there is a faction of the design community that looks at the energy consumption of mills, the chemical sludge of recycling, and the inherent risks of forestry, and they just decide the entire system is broken.
They want out.
They argue we need to completely decouple from wood fiber altogether. We need to make paper without trees,
And the text addresses this directly in its section on alternative paths, specifically tree-free paper.
The allure of tree-free paper is incredibly strong, but the text forces us to apply the exact same rigorous life cycle analysis to these alternatives as we do to wood pulp.
We can't just assume they are better.
Right, so the category is divided into organic and non-organic sources. Let's examine the organic alternatives first, specifically fast-growing annual crops like hemp, kanaf, and bamboo.
The argument for these crops seems so bulletproof at first glance.
It really does. Because an old-growth tree takes 80 years to mature, but a stalk of hemp reaches 10 feet tall and is ready for harvest in just 4 months.
The yield of fiber per acre is astronomical compared to a forest.
Yeah, many advocates treat hemp as a total panacea for the paper industry's woes. But the text throws a massive bucket of cold water on that enthusiasm.
Because it demands we look at the agricultural mechanisms required to achieve that massive, rapid growth.
Right. To pull that volume of biomass out of the soil in a matter of months requires intense agricultural intervention.
These crops often demand massive, repeated applications of nitrogen-heavy fertilizers and chemical pesticides.
And the runoff from those fertilizers creates huge dead zones in local water systems. Furthermore, 1,000 acres of industrial hemp is essentially a biological desert compared to a forest ecosystem.
It offers absolutely no diverse wildlife habitat.
It doesn't build deep soil ecology, and because it is harvested every single year, it doesn't permanently sequester carbon the way a mature tree does.
The text points out that many major environmental organizations explicitly do not advocate for replacing forests with these annual monocultures.
Wow.
The consensus in the source is that dedicated non-tree crops require significantly more research and development before they can be considered a holistically superior alternative to responsibly managed FSC forestry.
However, the text does highlight one organic tree-free avenue that holds immense promise, which is utilizing agricultural waste.
This goes right back to the concept of agricultural residues we touched on earlier.
Right. Instead of planting a crop just to make paper, we utilize the fibrous trash left over from the food supply chain. The text gives examples of papers made from banana stalks, coffee bean skins, and rice straw.
The logic here is totally airtight.
Because the environmental toll of cultivating the land, utilizing the water, and applying the fertilizer has already been absorbed by the production of the food crop.
Exactly. The leftover stock is an organic waste product that would otherwise just be burned, which releases its carbon immediately or just left to rot.
So by rescuing that waste and pulping it into paper, you are creating a high-value product with virtually zero new agricultural footprint.
It is brilliant.
I've actually seen high-end boutique packaging for organic coffee brands printed on paper that was actually manufactured from coffee waste.
Oh, that's fantastic.
It's a seamless fusion of the medium and the message. But what about the non-organic tree-free papers? The synthetics?
Synthetics.
We've all handled these stocks, right? They feel almost like a heavy plastic film. They are incredibly smooth, they're tear-resistant, and the ink sits perfectly on top of them because they aren't porous at all.
Synthetics are typically manufactured from petroleum-based plastic polymers or calcium carbonate mineral compounds. They completely bypass the need for water-intensive pulping and chemical bleaching.
And from a pure performance standpoint on a printing press, they are phenomenal.
They are, but the text identifies a fatal mechanical flaw at the very end of their life cycle.
The disposal mechanism is completely broken.
Entirely broken. While the manufacturers claim these synthetic sheets are recyclable, the reality on the ground is entirely different.
Standard municipal recycling facilities use optical scanners and float tanks that are designed specifically to sort and process cellulose wood fiber.
So when a dense plastic polymer or mineral sheet enters that highly calibrated stream,
the facility's machinery just registers it as a contaminant.
it jams the system.
Right, so the automated sorters simply kick those synthetic sheets out of the paper stream and reroute them directly to the landfill.
And because they are constructed of highly stable plastics or minerals, they will not biodegrade.
They will sit in that landfill for centuries. So you solve the problem of cutting down a tree, but you create a permanent, non-degradable garbage problem in exchange.
Which means, despite all the fascinating alternatives, the vast majority of our design work is going to be printed on some form of wood-derived paper.
And that brings us to the final, incredibly dangerous stage of the workflow. Because you've done all the research, you've navigated the chemical jargon, you balanced the PCW ratios, verified the FSC chain of custody, and selected the perfect mixed source sheet.
You package your file and send it to the commercial printer.
Right. And if you don't understand the mechanics of the printing press itself, you can instantly undo all your hard work.
Because the commercial printing process is highly toxic.
The text provides a rapid-fire checklist of fast steps to greener printing. First, minimize the physical weight of the paper. A 100-pound cover stock requires vastly more resources to produce and transport than an 80-pound stock.
Second, avoid specialty inks, particularly metallics and neons.
Why are they so bad?
Because the chemical formulations required to create a shimmering metallic gold or a blinding neon pink rely heavily on heavy metal compounds like copper, zinc, and barium.
And not only are these toxic to manufacture, but they are notoriously difficult to strip out during the froth flotation de-inking process we discussed earlier.
Third, specify water-based aqueous coatings instead of UV-cured varnishes, which complicate recycling.
But the most significant section here is the text's aggressive deconstruction of one of the industry's most beloved greenwashing tropes.
Soy ink.
Oh man, every designer has seen this. Clients absolutely love it. A printer proudly slaps a printed with soy ink badge on a carton, and everyone feels like they've single-handedly saved the environment.
That sounds so agrarian and pure.
But the text essentially calls it a massive illusion.
It is perhaps the most egregious example of marketing outpacing science in our entire industry.
Walk us through it. Why is it a myth?
To understand why soy ink is a myth, you really have to understand the mechanical formulation of printing ink. Ink is comprised of three main elements: the pigment, which provides the color, the modifiers, which control drying time, and the vehicle, which is the liquid medium that carries the pigment onto the paper.
And historically, that vehicle was highly volatile petroleum, right?
Right. And as environmental pressures mounted, ink manufacturers began substituting some of that petroleum vehicle with vegetable oils. Linseed oil, derived from flax, has actually been used in inks for centuries.
But in the late 20th century, the American soybean industry aggressively marketed soy oil as the ultimate eco-friendly alternative.
Yes. And here is the shocking mechanical reality the text exposes. There are incredibly lax regulations governing what can actually be labeled soy ink.
Lax.
An ink formulation can contain as little as 10 to 15% actual soy oil in its vehicle.
Wait, really? Only 10%?
Yes, with the remaining 85% comprised of the exact same toxic petroleum distillates, synthetic resins, and high VOC compounds as traditional ink.
But because it crosses that minimal 10% threshold, the printer gets to use the wholesome soy logo.
It is a profound misdirection. You are still dumping volatile organic compounds into the atmosphere, but hiding behind a tiny fraction of a vegetable byproduct.
Complicating that further is the macroecological impact of the soy industry itself. The text points out that several major environmental organizations actively urge designers to stop specifying soy ink.
Why is that?
Because the explosive global demand for soybeans is a primary driver of catastrophic deforestation. Massive tracts of the Amazon rainforest are being illegally clear-cut and burned not for timber, but to create massive agricultural lands to grow soybeans.
Oh, wow. So a designer who insists on soy ink, genuinely believing they are making an ecologically pure choice,
might actually be financially supporting the destruction of the world's most critical carbon sink, while still off-gassing petroleum VOCs in their local community.
It is a devastating critique. The text advises designers to ignore the word soy entirely. The origin of the vegetable oil, whether it is soy, linseed, or cottonseed, is largely irrelevant.
The metric that actually matters is the VOC content.
Exactly. A designer must explicitly ask the printer for low VOC or zero VOC inks.
Okay, so controlling the ink is vital, but managing the mechanics of the press itself is the next frontier. Traditional offset lithography relies on a fundamental chemical principle: oil and water do not mix.
The metal printing plate is chemically treated so that the image areas attract the oil-based ink, and the non-image areas attract a thin layer of water.
And the press uses a dampening system to constantly bathe the plate in a fountain solution, which is a mixture of water and isopropyl alcohol, just to keep the ink from smearing into the white space.
And that fountain solution is an environmental nightmare. The isopropyl alcohol evaporates instantly, flooding the print shop with massive amounts of VOCs, and the contaminated wastewater must be handled as hazardous material.
But the text is incredibly optimistic about a technological paradigm shift called waterless printing.
Waterless printing fundamentally alters the mechanics of the plate itself. Instead of relying on a toxic chemical balance of water and alcohol to repel the ink, a waterless plate is coated in a layer of synthetic silicone rubber.
So the silicone physically repels the ink.
Yes.
Meaning you completely eliminate the dampening system. No water, no alcohol, no fountain solution.
Exactly. But removing the water creates a brand new physical challenge: friction.
Because an offset press runs at blinding speeds, right?
Right. Without the water acting as a coolant, the metal rollers generate immense heat. If traditional ink gets too hot, its viscosity drops. It becomes runny and simply smears across the silicone.
So how does a waterless press function without turning into a smeared mess?
Through aggressive microscopic temperature control. Waterless presses feature hollow rollers that continuously pump chilled water right through their cores.
I see.
This precise chilling system keeps the specialized inks at the exact optimal viscosity, ensuring they only ever adhere to the image areas.
The environmental benefits are pretty obvious. Zero contaminated wastewater and a drastic reduction in atmospheric VOCs. But what really fascinated me in the text is the economic argument for the printer.
The economic upside is massive because the printer doesn't have to spend hours tweaking the delicate chemical balance of ink and water to get a clean image. The setup time is totally slashed.
So they get up to color, meaning the printed sheets match the proof perfectly, almost immediately.
The text actually cites a staggering 100% increase in productivity for print shops that retrofit their machines for waterless technology.
That's 100%.
Yes, they run faster, they print sharper dot structures, and they generate a fraction of the paper waste during setup.
The barrier to adoption is simply the upfront capital required to install the chilling systems and buy the specialized plates. But for massive corporate runs, it is undeniably the future.
However, if a designer isn't printing 50,000 corporate catalogs, if they're only designing a run of 500 conference invitations,
putting that job on an offset press, even a waterless one, is incredibly wasteful.
For short runs, the text directs designers toward digital printing.
Let's look at the mechanics of digital. Why is it inherently greener for small batches?
Because it completely bypasses the physical architecture of offset printing. There are no heavy aluminum plates to manufacture and chemically burn. There are no massive ink rollers to wash down with toxic solvents between jobs.
Right. High-end digital presses using toner technology operate essentially like massive laser printers.
They use electrostatic charges to attract dry plastic pigment powder to the paper and then flash fuse it with intense heat.
It is a completely dry process. Zero water is contaminated, zero alcohol fountain solutions are used, and toner emits virtually zero VOCs. Furthermore, the first sheet out of a digital press looks exactly like the 500th sheet.
The setup waste, the hundreds of sheets of paper and offset press ruins while dialing in the color registration is entirely eliminated.
So for any project requiring fewer than 2,000 copies, digital printing is structurally the most resource-efficient choice.
Without a doubt.
So we have covered the theory, the chemistry, the forestry, and the mechanical engineering of the press. Let's ground all of this complex theory into practical application. The final section of this chapter acts as a literal cheat sheet.
It's a dense chart evaluating specific brands of environmentally friendly papers.
And it is the most vital tool in the text because it forces the designer to weigh the inherent trade-offs of every single spec. You have to balance the client's budget, the desired aesthetic, and the environmental purity of the sheet.
Let's run a hypothetical scenario using the chart.
Okay, let's role play. Say I am designing a 50-page corporate social responsibility report for a major tech firm. They want it to look incredibly premium, full of high-resolution photography, but they are terrified of being accused of greenwashing.
They demand the most ecologically pure paper available.
Right. So I look at the chart and I pitch them the Cascades Roland Enviro 100.
If you are optimizing purely for environmental metrics, it is a flawless choice. The specs are impeccable. It is 100% post-consumer waste, meaning absolutely no virgin trees were harvested.
It is processed chlorine-free, mitigating the dioxin risk.
And it is manufactured using biogas energy captured from a local landfill, meaning it operates on renewable energy.
I pitch those specs, and the client is thrilled, but then I get the quote back from the commercial printer, and the client totally balks at the price.
The economic friction derails the pitch.
And this is exactly where the designer must understand the production notes in the chart.
The text explicitly warns that this 100% PCW sheet is one of the most expensive options available. The intense cleaning required to process that much waste fiber drives the cost up exponentially.
Furthermore, because it is an uncoated, heavily recycled sheet, the ink absorption is very high.
It requires longer drying times on the press, which means the printer will literally charge you for the extra time the job just sits on their floor drying.
So the client says they can't afford the premium. I have to pivot. I look at the chart and see the Costa Rica natural paper. This utilizes agricultural residues.
Mm-hmm.
Banana fiber. I pitched the idea of printing their sustainability report on paper made from recycled fruit waste.
It's an incredible conceptual hook.
It really is.
But you have to evaluate the mechanical performance. The chart notes it's an uncoated sheet with a very distinct organic texture. If your 50-page report relies on crisp, high contrast, razor-sharp architectural photography,
Printing it on highly textured banana paper will result in massive dot gain. The ink will bleed into the fibers and the photos will look muddy and soft.
the aesthetic goal of the project will fail.
So I have to find the pragmatic middle ground we discussed earlier. I look at the major industrial mills listed in the chart, companies like Mohawk, Sappi, and Neenah.
This is where you find the workhorse sheets. You pitch a Mohawk mixed source option. The chart shows it contains 30% post-consumer waste, supporting the recycling stream.
While the remaining 70% is FSC-certified, totally chlorine-free virgin fiber, providing the bright, smooth surface needed for high-resolution photography.
And the mill offsets its energy with wind power credits.
It doesn't have the conceptual purity of 100% PCW or the nanofiber, but it performs flawlessly on press, the client's photography looks stunning, and it actually fits within the corporate budget.
The ultimate advice the text provides to a designer navigating this exact friction is to stop treating sustainable paper as a boutique special order item.
Have a serious conversation with your commercial printer. Advise them to evaluate these mixed source sheets from Mohawk or Sappi, and select one to be their standard house sheet.
Because if the printer buys that mixed source paper in massive bulk on huge skids, the economies of scale completely erase the boutique price premium.
It stops being a costly green upgrade for the client. It just becomes the new, affordable default standard. You basically design the friction right out of the transaction.
It elevates the baseline of the entire industry.
Well, we have covered an immense landscape today. We started by questioning the very right of a design to even exist in the physical world.
We navigated the genetic preservation of Canadian pine forests.
We waded through the violent chemistry of lignin, chlorine dioxins, and the toxic froth of de-inking sludge. We shattered the marketing illusion of soy ink.
Detailed the thermomechanical genius of waterless printing.
And role-played the economic friction of specifying paper to a tight-fisted client.
It is a massive intellectual undertaking. The text demands that we respect the physical materials of our craft.
Because graphic design is not just a digital file manipulated on a screen, it is a profound orchestration of forestry, chemistry, and heavy industrial manufacturing.
And before we close, we want to leave you with one final, provocative thought.
It's kind of an extrapolation of the text's core principles applied to our current moment. Throughout this entire deep dive, the underlying assumption, the holy grail of step 2 in the workflow, is that shifting away from physical print and moving toward digital distribution is inherently the greener choice.
We assume that to save the trees, we must shift our designs to the cloud.
But we must apply the exact same rigorous life cycle analysis to the cloud that we just applied to a paper mill.
The cloud is not an ephemeral mist.
Right. It is physical infrastructure. It is millions of massive, warehouse-sized server farms packed with lithium and rare earth metals, requiring staggering amounts of electricity to process data.
And monumental air conditioning systems to keep from literally melting down.
So the question we want you to ponder as you return to your studio is this. Is a digital pixel hosted on a server farm, powered by burning coal, drawing electricity in perpetuity every single time a user loads the web page?
Is that actually greener than a perfectly sourced 30% mixed source, waterless printed piece of paper that requires zero energy to view and eventually biodegrades naturally back into the soil?
It forces you to confront the invisible, continuous carbon footprint of digital design.
There are no simple answers, but a truly sustainable practitioner must be willing to interrogate both the physical and the digital realms.
Keep asking the hard questions. Thank you so much for dedicating your time to understanding the complex mechanisms of this profession. If you found this deep dive illuminating, please hit subscribe on the channel. It allows us to keep breaking down these critical texts for you.
And again, if you want the definitive guide on your desk, scan the QR code or click the link below to get your own copy of Graphic Design Reference plus Specification.
Beyond the wealth of knowledge, there is just a profound tactile joy in holding a sustainably manufactured, beautifully designed book. It proves that production and preservation can actually coexist.
Until next time, keep pushing for better materials, keep challenging the defaults.
And we will see you on the next deep dive.